Hey everyone, I'm Darren Mart, the developer of Montage Studio. Before I dive in, I'll give a quick recap of what Montage Studio actually is. In a nutshell, it's going to be a platform that makes it insanely easy to build interactive apps and games for the web. And the core building blocks of those apps are what I call scenarios, which have 3 steps. You'll choose a command, then you'll choose a target, and then you'll behold the magic that ensues. And so for this dev blog video, I'm going to focus on the second part there, which is choosing a target, specifically how Montage Studio figures out which visual you're trying to interact with. Alright, so I'm just going to dive right in with the scene that I've been using as kind of a workshop. It just has a background image and one character. And just a quick note, you'll have to forgive me for the character right now, which is just a placeholder. Nobody should ever wonder why I use AI tools like Midjourney for the graphics, because if I don't, you'll end up with stuff like that. So anyway, back to the scene. And so in this scene, our character can walk back and forth. We've got scrolling going on as we need it. But then the character can also walk into the scene, right, to give the illusion of depth. Now, you'll notice that as I walk into the scene and as I mouse over the character, the target appears at the bottom left there. And believe it or not, there's quite a bit of work that goes into making that happen. Now, if you happen to be a web developer, you might be thinking, well, that's pretty easy, Darren. All you got to do is wire up a mouse event on the element and call it a day. Well, it's not quite that simple, and I'll show you why. So the character that you see on the screen is actually just one frame of a larger image, something I'm calling a sprite sheet. It's got a bunch of different frames for, different animations like walking and talking and blinking and so forth. And so the element that contains the character needs to leave a lot of room for those animations to happen without clipping anything on any of the sides. So you have quite a lot of space that's useful from an animation perspective, but not so much from a targeting perspective, right? You don't want this happening where any of that occupied space in the bounding box would register as the target. And here's another example of why I can't use the mouse events that the browser gives me for free. It looks like we have a character here with what appears to be a chest right behind him. Now keep an eye on the target that appears down here as I mouse over different elements. As you would expect, as I mouse over here, I get the chest as the target. If I go up here into this territory, I get Henry as the target. But what do you think happens when I mouse over the space that's occupied by both of them, where it overlaps? I only get Henry as the target. And the reason for that is because I need to use z-indexes to give the illusion of one visual being in front of another one. And native browser events are only going to fire for the visual that is in front. It's not going to give me both targets. And that's a problem. You would expect that the user is going to click right here and get the chest as the target, but instead it's going to get the character. So this is why I had to come up with my own coordinate system to figure out which visuals occupy a particular space and which ones are eligible to be the target, and then I can figure it out from there. And so the coordinate system was working out pretty well until I started to implement a couple of different things related to scaling. So the character itself has an assigned scale that can be changed per scene. You can imagine some scenes will be more pulled back in terms of the camera lens, other scenes will be more of a close-up, so you have that scale that can change per scene. Then you also have this depth-related scaling, which I'm calling the Z-plane, which you can just imagine as 2 lines going across the scene, one that would specify what is the minimum scale, and another line that shows what is the maximum scale. So as the character moves back and forth, that scale is also applied. But then you also have a third scale, and that is the scene itself. So remember that we're in a browser here, and a browser window can be resized. So as the browser is resized, I also need to scale the scene to keep in the viewport and to scale with the viewport and keep everything scaled appropriately. So as you can imagine, this is quite a bit going on at once, and what I noticed is that if I would walk the character to the back of the scene, even if my mouse were way up here, the target was still registering as the character. And if you're a developer, you might have ideas on why that is. So let's dive into that. Alright, so I've added a little bit of debugging here, and what I've done is I've set this visuals scale to 1, which is the default. And you'll see that it's reporting its coordinates as 500 to the left and 700 from the top. That's pretty much how all visuals are placed in the scene, based on their left and top coordinates. And as I mouse around that corner, you'll see that it's pretty close based on the debugging information up here. It's pretty close to 500, 700. It's not exact because the scene itself has some scaling applied, but it's close enough for this purpose. Now what I'm going to do is I'm going to change the scale of that visual to 2, twice the default. We'll refresh the scene, and you'll notice that the visual is still reporting its coordinates as 500, 700, even though if I mouse around that corner, it's clearly not even close. Now, the reason for this is how CSS transforms work. The browser will position an element where you tell it to in terms of left and top coordinates, but then it will apply any transforms, in this case a scale transform, after the fact. And it won't care what the eye can see is clearly the top left corner of the visual. It's just going to apply the transform and be done with it. In this case, it's applying a transform from the bottom center of the visual. And so that's why I needed to come up with a system that would basically calculate, regardless of what the reported position of a visual is, what is the effective top left and bottom right corners of the visual after the scales and other transforms have been applied, so that I know what is the actual targetable area of a visual. And after all that, hopefully you now appreciate what it takes to be able to target a visual after it's been scaled. And that's pretty much a wrap. Thank you for tuning in to the first devlog video for Montage Studio. I can't wait to get this platform released, not just to make my own apps and games, but to see what other people come up with. Until then, thanks again for tuning in, and I'll see you next time.